So we're going to take a look at question number 3, which asks to solve a problem symbolically, and it asks two identical cannons fire projectiles of mass m at speed v0. One cannon is on the ground, and the other is at the top of a tower of height h, above the other cannon. The two cannons are aimed directly at each other so that the lower cannon makes an angle of theta with the ground. If they are fired simultaneously, projectiles collide. How much time delta t passes before collision? Answer symbolically. So we'll start off with what we do know. We know that the final height is equal to the initial height. Or, the final height of one of the projectiles equals the final height of the other projectile. And using the position update formula, we can find that the final height for the first cannon, cannon 1, here's cannon 2, is equal to RIY1 plus V average delta T. And we know that since it's on the ground, its initial height is 0, and the average speed will be V0 sine of theta delta t, which is the magnitude of the velocity times the direction of the velocity. As you see here, that is equal to the magnitude of the vector times the unit vector. The velocity vector is equal to the magnitude of the unit vector, which is the speed, times the unit vector. So the final height of the second cannonball is V0 sine of theta delta t, which is the same as the final height for the second cannonball. So we can use another position update formula where RFY2 is equal to RIY2 plus V average delta t y2, and we know from that RFY2 is V0 sine of theta delta t, which is equal to the height, and the initial height of the second cannonball is at h, and we will add in the average velocity there. So V0 sine of theta delta t is equal to h minus V0 sine of theta delta t. Add V0 sine of theta delta t to both sides, and we get V0 sine of theta delta t, so we'll get 2 V0 sine of theta delta t is equal to the height. So if we divide by 2 V0 sine of theta on both sides, we will get delta t, the time that it takes for the cannonballs to collide. And then part B, we will look at how to determine height of projectiles relative to ground at collision, when the two projectiles collide. So starting with the momentum principle, delta py2 is equal to f net y to delta t, which is equal to negative mg delta t, and the mass times the velocity is momentum, so we can do m fy2 minus v mviy2, divide both sides by m, and we get vfy2 minus viy2 is equal to negative g delta t. So vfy2 is equal to viy2 plus g delta t. So we know that that is equal to negative V0 sine of theta minus g delta t. So that's the final velocity of the second cannonball. And then we can find the average velocity by taking the arithmetic average of the two. And then we just plug in our previous answers. means we know that the final height is the same for both projectiles. And then plugging in the position update formula for the second cannonball, we can get the answer. So we multiply the average by delta t, and then we can use the answer that we found from part A to plug in for delta t. And that is also equal to the final height of the first one. And so if you want to make this problem, so there's our answers, and if you want to make this problem more challenging, or you want to look at it from another side, you could perhaps try to solve the problem with this given with this angle measure instead of this one, to see how you can do with different trigonometric ratios, or you could try to use different you could try to use the distance instead of the height, or you could try to just see how long it takes one cannonball fired by itself to reach the ground, or any other problems like that to test your knowledge. And that'll be all.